Memory consists of three processes: sensory memory, short-term, also known as working memory, and long-term memory. The first step occurs when info is processed through the brief period of sensory memory. This is when memory occurs through each of the senses. For example, being so engrossed in reading a book that someone asks you a question and you immediately say "what?" because you were so involved in reading that you didn't hear the question. In the second stage, short-term memory, only a small percent of information is passed from the sensory stage. This stage, although longer than sensory memory, is still brief. The capacity of short-term memory is limited. For example, a phone number said repeatedly until entered into the phone. The last stage, long-term memory, is somewhat permanent and can last for decades. Long-term memory is broken into two categories: non-declarative and declarative memory. Non-declarative memory we are unconscious of. It tends to occur automatically. For example, driving a car. Declarative memory involves events and facts that we are able to verbalize. For example, your surprise 30th birthday party. Some short-term memories are transferred to long-term memory. The structures involved in memory include the hippocampus, amygdala, and the cerebellum. The prefrontal cortex is also involved. The hippocampus is responsible for recognition memory as well as declarative memory. The amygdala's role is fear and memories associated with fear. Memory is a subcortical process. Without it, we would not be able to learn anything. Our memory gives us the ability to store and retrieve information. Environmental influences are significant to the development of memory and learning and the learning process. Our emotions at any given time affect how we learn and process information, and subsequently what we will remember. Communication is carried out at a neurological level because anything related to speaking, for example, thinking about speaking, watching other people speak, and actually speaking, all activate regions of the brain responsible for language. This suggests neurons are involved in speech and language comprehension.